Hello and welcome back to Calculus2. We are talking about surface area of revolution. So take your coffee cups, take your mugs, take the water bottle. As long as it's circular in the cross-section, that means that the object can be obtained by rotating a function which is outlining the edge of the shape. The following formula will be calculating the surface area of the bottle or the cup or whatever you have. So we are going to build this up from the previous concept, which was length of the curve. So we know from previous class that length of the curve A to B was the square root of 1 plus the derivative squared dx. Now length, this would be the length of the function which you are going to rotate to create the shape. We calculated the square root, the length of a few curves on the last lecture. So one thing that I forgot to mention is the dimensions, and to verify using dimensional analysis that this is one-dimensional formula. We know that length is one-dimensional, area is 2D, and volume is 3D. So the variables inside of this formula for length have to add to 1. And you already see that that value is taken by dx, which means that the square root portion is not allowed to bring a dimension. And it doesn't, because the square and the square root roughly cancel, right? There's the 1 plus, so you can't cancel them, but they do, the root and counters the square, and then the integral counters the derivative, right? So as you can see, this is the one-dimensional entity. The only thing that will remain is actually the function, because the integral dx cancels with the derivative, square cancels with the square root, and the only thing that is left behind is f of x, which is 1d. F of x is just y dimension, right? So what we are looking in today is the area, which means that we need another dimension, and it's a surface of revolution. So what is that we need? Well, if you think about the shape and what we are doing, I have some kind of function f of x here, which is to be rotated, let's say, on x-axis. So this radius here is actually f of x. I know that the length of this curve over here from, say, A to B, the length of that curve is L. So wouldn't it make sense, knowing that area of the circle is r squared pi, wouldn't it make sense, since we have now something close to the rectangle, to say r times L times pi? Pi doesn't bring a dimension to anything, only r and L would. So what is the surface area of revolution? It's going to be 2 pi integral a to b, and then we have f of x square root of 1 plus f prime squared of x dx. So you have the 2 pi. So let me outline this. So you have your 2 pi times the length. That gives us the circumference. Sorry, that's not this one. The radius. So 2 pi r is the circumference, and then times the length of the whole. So maybe I should underline it twice. So here's your 2 pi r is the single underlined once, That's the circumference of the circle, and then times the square root, which is the length. So you know that the width times length is the area. So the formula clearly makes sense. We also have the one for dy, just put y's everywhere. So this is the formula that you guys will remember. And you see it's the same as the L, except you are adding rotation with the 2 pi and the radius to bump the dimension where you need it. The other formula for y is just s 2 pi c to d f of y square root of 1 plus f prime squared of y dy. So it's the same. The upper one is the rotation on x, and the one on the bottom is the rotation on y. We do not have any type of a shell equivalent to kind of mix and match whether we want this way or that way. So this is all you get. If the integral gets too crazy, well, such is life. Use Mathematica. The lesson is over. Now we do examples. That's it. I hope you're not disappointed, but that's it. So now we do examples. Just by having this component again of 1 plus f prime, that means that the trick we learned last time with expanding and contracting still works. But the beautiful thing is that this f of x in front of the square root opens many new possibilities to use u sub rather than that trick. So in some cases you will be using u sub, and in other cases you will actually have to use the manipulation we had last class. So here is the first example, problem 8. Compute f of x is given as x cubed. They want that on 0 to 1 interval. They want the surface area, obviously, and it's rotating on x-axis, so you will use the x formula. So you should be able to do this. You have the formula, plug everything in, see how it goes. Okay, so now what? Yeah.
What I told them in the beginning of class, I'm like, they got chips here, and Adam's got this big bottle of like, they're not in a party.
Yeah, well, we can have a, guys, you want to organize the food party over here? Anytime. I am in. Everyone brings one item and then just like crazy for 3 hours.
This drops the denominator down to 9, 9 times 3 is 27.
I thought that initially
Pi over 27, and then you just times 3 over 2, evaluate from 10 to 1.
I'm going to get the answers.
That's fine.
Instead of that, I'd say once a month. Yeah. 6 seconds. Breakfast.
What?
Oh, yeah.
She's like, she was confused that I eat cereal once a year.
A year?
Yeah. It's like cardboard. No, that's what I got. Just tell you.
What I think about
I mean, yes, but it tastes so good.
every place thought you guys,
Nope, no.
I canceled them out, I redid the numbers, they got 7 1 and
I've seen a 1 to 10. That's 1 to 7.
it's like this. The number for 1 0 we said, which I plugged in.
But what is 66 times?
It's 3x squared. You said the derivative.
Yeah, that's
3x squared, and then you have squared in the thing. 3 squared.
Bitch, that's what I did wrong.
3 squared.
I keep doing the differentiation of square root of u instead of the integral of it.
3 squared is 9. So it should be 9 to the 4, right? And then you go from there. So if the
Oh, that's the
limits
limits.
1 to 10.
So if we had 0 and 1, you had to plug it into the u. We got 1 and 2. She has different voices. It's a little frightening. Yeah, honestly, like it's different.
Oh, that's probably for markers and stuff. It's that no one washes in water. That's these markers. Cool, it's expensive.
Right, exactly. Yeah.
It's cool because you're never alone. I like it. Yeah. my voice cracking?
No, but when you do like go back.
But that's the deep laugh. That's not me. That's channeled through me. That yeah, I don't know.
Do you have multiple personalities?
Yeah, I was gonna be like.
No, I only have one, but I do get possessed by other entities.
Sounds about right.
Which is the reason why no one people usually don't stay along with me in anyone's spot.
Makes sense.
So all this trouble packs whenever you're around him.
Okay, yeah. But also the size of the pack, because I am legion, so there's at least 666 voices.
I'm sorry, what?
Don't worry about it.
I'm Legion.
Oh my god. You just write like an autobiography and like include this. Like if you ever write a book.
No,
like,
if you
under your
write an
belt,
autobiography, if he writes an autobiography about himself, it would literally get frightening. Like after a while, you just want to stop reading. Just like, what the hell?
Let's go. We have a shape, which is the cubic function. We're only considering the part from 0 to 1, which will be rotated around x-axis, which looks like this. And we are computing the surface area of this. This is not a cone, but it's almost a cone. Okay. So what I have, oh, this is nicely curved. So as you can see over here, my bleach, it's curved. So we are looking for the surface area of this type of a shape now. So S is equal to 2 pi integral 0 to 1. Those are our limits. And we have x cubed and then the square root of 1 plus the derivative, which is 3x squared, and then we have to square that dx. That gives us 2 pi integral 0 to 1 x cubed, and then under the square root I have 1 plus 9x to the 4th dx. U is equal to 1 plus 9x to the 4, and the du is equal to 36 x cubed dx. I don't have 36, so I'm going to put 36 in here and divide by 36 outside to make necessary substitution. So that turns into pi over 18 integral. We have to change our limits, which becomes 1 to 10 now. When we plug in 0 into 1 plus, what happened with the equal sign there? When we plug in 0 here, it kills the 9x to the 4th term. We just have 1. And then when we plug in 1 to the 4th times 9 plus 1 is 10. And all we get here is the square root of u du. So that's pi over 18. And we have u to the 3 halves divided by 3 halves. We put the 2 on top. 0 to 10. No, 1 to 10. 1 to 10. 2 and 18 will cancel, and then get the 9 times 3, 27. So pi over 27, which gets us 10 to the 3 halves minus 1. And that's the answer.
We're just supposed to leave this 10 to 3 halves?
Well, usually my MATLAB wants you to have it like this.
1,000 anyway.
It's the square root of, yeah, it's the 10 root 10, yes.
And how you get the pi over 27, it shouldn't be possible to do that. But,
Well, you can approximate. Pi is almost 3, right? So the whole thing over there is about 1 over 9. 1 over 9 is about 1 over 9 is about 0.11111. So the whole thing is about 0.1, and then the rest. So not really. Yes.
Oh, for a question like that, is it okay if we answer that as a decimal? Right?
Yeah, but that takes additional energy. The first rule of physics and everyone is just that all of the objects would like to stay in the minimum, on the minimum energy state, which means universe is lazy by default. So that requires more. If you want to do so, you go ahead, do it, right? Does it paint a better picture of you because you were not lazy? I don't know.
Either way, if you're doing this on my math lab, it'll always ask you for the exact answer.
Yes, so this is, I left it here because this is what my MATLAB asks you to plug in. But can you do the decimal? I am very confident in your skills. Any other questions, concerns regarding, yes?
Why did we change the upper and lower limits to 10 and 1?
Because we were using U substitution. These limits, 0 and 1, they are X limits, from X1 to X2, right? And as I'm changing domain from X domain to U domain, the limits have to match. So in the original problem, it was X, 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 X everywhere, right, dx. The new limits have to be U and U, and we just used the U transformation to change them, right? So I used this 0 in the U substitution here to come up with 1, right? So that's, and then I used 1 in the same combination. So you use the transformation. You are transforming the integral. So yeah, this is much more interesting in Calc 3. Takes about 40 minutes. With the 3x3 Jacobian matrix, it's awesome. Do I have it? I have it. Same thing in Calc 3 for multiple variables. Problem starts there, and then you do some transformations, and you do Jacobian. This is a 2D, this easy case. And then I said solve by parts twice. Here's the 3D Jacobian matrix and the equation. You just plug stuff in and you go on. It looks so scary, but it's so simple. When you start building the concepts, guys, you have no idea how simple. Every single student who took Calc 1, 2, and 3 says Calc 3 easiest, then Calc 1, and then Calc 2. Calc 2 is always the one that it's boo.
Differential equation is really easy.
Depends on how well you integrate and how good you are with the plus C.
Because I met like this girl, honestly, who's from like the Navy, as they thought that she's doing like a single major, triple minor, but of course he said it's very easy, differential equations.
Well, and probably it's all in depends on. For me, Calc 2 was the worst by far, and the other ones were a complete joke. That's how I considered all other 1, 3, and DiffyQ were all jokes, and Calc 2 was really. All right, one more of these guys. What are you going to enjoy? Here, I know you like also to explore revolving around y. We shouldn't discriminate, so let's do that. Y equals x squared over 4. This is problem 18, if you are following in your textbooks. For 2 less equal than x less equal than 4. So let's see how that goes. And then we're done with this section.
write the equation, like x equals, are we just using the positive one? The positive root? Correct?
Yeah, because look at the limits.
Yeah, so that's what I was
Two to four.
thinking.
Yep.
2 to 4, correct.
Hey, I got a quick question.
Yes.
So first of all, I did what you said, and I made it x equals, and when I tried, I really got brain, by accident, I think I did the wrong intervals, but at the very end, I got square root 4y 1 plus, but I don't know how you do the f derivative of square root 4y.
Just do the regular derivation. That's how you regulate the second one.
Yeah.
So it's the same as if you were taking
C and D.
Like, I know, it's like, you say u equals 4y.
root of 4y. So what's the derivative? Like what would be the derivative of root 4x?
4x.
Square root of 4x.
Be like u equals 4x to 1 half.
Yeah.
Be like 2/3, and then you got 4x to 3 halves.
No, this is
See, this is the derivative. Gotta be written as y.
the derivative drops the exponent.
So yeah, 1 half, so be 1 half over to negative 1 half then.
This is
Yeah, which is 4.
Same thing.
No,
It's
I'm
like
gonna
1
figure
for
out
x.
how to fix those.
And then there's more algebra coming later. Put it all together.
Oh,
Professor,
Yeah, well,
how do you
what
calculate
if you
C
said
and D?
2 is equal to 2 squared y? And that would be 1, and 4 is equal to 4.
Is this C and D? Yeah, no.
Exactly.
But if we set this, yeah, so if we have the x equals 1 plus minus 4y, set the x equals 0, and then you square that, you say y equals 0.
Okay, we're gonna put back up that.
what are the roots? What is the what is the word in a nutshell? What then it means? What kind of values?
So
What
we're
are
ready
the
to
values? What are the CMD?
y values.
Good. How do you calculate y values at x equals?
You need to explain it better, please. I need you to explain it a lot better. Like, basically, what I did is,
That's what it means.
And like, do you just
but
do
then, how would I be able to do it with the 1? Like, do I have to square out everything now?
Well, think about it. It would be 2 square root of y, and then.
I know, like 4 and then 4y.
Oh.
Yeah, 1 over y.
Correct?
But then I would have to multiply.
This is the square root of 4y is equal to x. We need to differentiate that, then square. We're about to differentiate and square.
So it'll be like y plus by 1. So you still have for 4y.
That would be 1 over
Take
square root of y.
y. And multiply it like,
Yeah, root 1 plus 1 over y.
Of 2 square root of y would be 1 over square root of y.
so what, how would I combine this one? So it'll be, like this, like, root is everything by 4y parentheses.
So even if you have
1
2,
change y plus by 1.
Oh, because it's square.
Okay. 4y squared plus by 4y over y.
No, just cancel the y. Y is One denominator, one
One plus 1 over y. Derivative of you said
So
that
this
1
would be
over y.
4y plus by 4.
You have to keep 4 outside. Because 4 is 2, right?
Yeah,
You
you do.
and you do 5 plus 5.
So
This form, this y gets
Yeah.
cancelled in this form.
Yeah.
And then you can jump over there.
it'll be 2 then.
Well, yeah, because what I had done was
And be
um,
y plus y 1 still. So I do u y
No,
plus by 1
basically
and then
proof,
du dx equals 1 equals
the square root of
u
y
equals
is
1
equal to
half
1
sorry.
yeah.
Seconds. All right, let's take a look at this problem together.
Yeah, right.
So I like to draw these things so that I can see them. The reason why I like to do that is limits. I know it's a y rotation. I know I have to flip the function, but then just in case, because I need to know where those limits are. And I have the shape. So x is equal to, sorry, y equals to x squared over 4. So that's just x squared graph. It's going to be wider than usual. And we're talking 2 to 4. So I'll just say this is 2 to 4. Right, 2 and 4, whatever. That's the portion of the graph. I'm rotating on the y-axis. So that means that's how it looks like. It is this portion of the function that it's important, and that's the portion of the function which rotates. So, you know, without the picture, you shouldn't be able to figure stuff out in terms of limits and what goes where. Because rotation on y triggers dy, and that triggers our limits c and d in terms of y. The numbers that you have over there are 2 and 4. They're x numbers. So you have to plug those numbers into an equation to come up with the y values. So number 2 will be 2 squared is 4, 4 over 4, so that's 1, less than y, less than 4 squared is 16, it's 4. So you have your C and D as 1 and 4, which you get from, now further to understand this, if you care, would be that this point here is the point 4, 4, and this point here is the point 2, 1. So once you are able to locate the point, you also have the x and the y value. So no matter which way the rotation goes, you will have the limits to fix the to put the integral together. So now s is equal to 2 pi, integral goes from 1 to 4, and we have the function. Now we have to flip the function, and as you can see from the graph, once we flip this function, we are going to get x squared is equal to 4y, and then x is equal to plus minus square root of 4y. Now that is plus minus 2 root y, if that's going to make you happy. Now, plus minus. There is a plus portion of the graph and the minus portion of the graph, okay? We only need the plus portion. So you have to get both because they exist. You see the picture, right? So both of those exist. I am going to use the positive one because that is the one that I am rotating. So this is going to be 2 root y square root of 1 plus, and now I need the derivative of this. The derivative of root y would be 1 over 2 root y, and then 2 and 2. So I believe this is just this, and then it has to be squared, right? And you have the dy. I'm going to move this so it's not in a way. X equals to plus minus 2y. There we go. So now I have my 2 that goes in front, makes it a 4 pi. and then I have the integral of 1 to 4. Root y stays there, and I just want to work this, and that's 1 plus 1 over y, and then dy. Now, the rule in algebra says square root of a times square root of b is square root of ab. Now, I don't care whether you have just numbers or variables or entire functions. The square root rule applies, which means that the first y will multiply the second root, and that will simplify all of this greatly. So I have 4 pi integral 1 to 4. Square root of y times 1 is y, and then y and y would cancel, so y plus 1 dy. We hit it with a u sub. And problem done. We will be changing limits again because we are as soon as you have to use u sub, limits must change immediately. That's a given. So that has to happen. So we have our u to 1/2 du. The limit of 1 becomes 2, and the limit of 4 becomes 5. So 4 pi u 3 halves over 3 halves from 2 to 5, which is 8 pi over 3 times 5 to the 3 halves minus 2 to the 3 halves. And then now you calculator masters can take over and get this down to the 8th decimal place. The answer should be around 33. Somewhere in the vicinity.
5 over 3 times 5, you have 5 minus 2. That's cool.
Calculus.
Do you know that my math lab marks you wrong if you put your pi in front of a radical? Yeah.
Wow.
Well, let me just end the stream because this is it for this section. We're going to take the break and then do the next section.